All right, so it says Anthony is standing on top of a building 11 meters high, and is holding a 4 kilogram bowling ball. Mildred dug a hole 5 feet deep next to the base of the building. What is the gravitational potential energy for the bowling ball relative to the hole? Okay, so it's first thing in the morning. I really tripped up my words, but let's do a building. Oh, this is perfect. Here we go. I like that one. I used to draw all these things. Actually, that is probably way higher than 11 meters, but that's okay. So there's my building, and then over here in the grass, they dug a hole. So the grass is like this. And then there's this dark hole right here. So from here to here is 11 meters. And actually, that's not a deep enough hole, because 5 meters would be almost half the size of the building, right? So to draw it in perspective. Shoot. So from here to here is 5 meters. And from here to here is 11 meters. And then we need a bowling ball. Perfect. Let's do this one. I like this one. All right, perfect. All right, so this has, we got to go through and label everything. This has a mass of 4 kilograms. Okay. So then what is the gravitational potential energy? Well, the first thing that we need to do is get rid of this bowling ball. Well, remember that the gravitational potential energy has a formula. That formula, U for potential energy, is equal to the mass of the object times the acceleration due to gravity times y. And sometimes you'll see this in textbooks as mgh. But it's just the total displacement in the y direction. So my potential energy then would be the mass of the object, 4 kilograms, times the acceleration due to gravity, which is 9.8. Shoot, it's getting a little sloppy here. 9.8 meters per second squared times 11 plus 5, which is 16, right? So remember that 11 plus 5 equals 16 meters. So the total displacement in the y direction is 16 meters. So when you multiply that out, it's basically 627. And remember the measurement for joules. And we have to make sure we're keeping everything in the right units. So this is in kilograms, this is in meters. It all works out to be joules, capital J. So that should be the answer. So let's see if that's one of the choices. It looks like they rounded up to 630, right? And that has to do with significant digits, but that's okay. So about 630 joules. Any questions? All right. I spent more time on the picture than actually explaining and doing the math.